Hello Year 5 and welcome to Week 7 Wednesday's maths session. This week we've been looking in mental maths at our number bonds. We've explored number bonds to 100 and 1000, and yesterday we also looked at number bonds to 1 and to 10 with decimal numbers. Now today it's going to be about you choosing your own level of challenge to play the game Hit the Button, which I'm sure is familiar to lots of you. On your task sheet today there is a link that takes you to Hit the Button, which should come up with a page like this, and this little button here makes it full screen. So you're going to click on the number bonds option first, and then second of all you're going to choose your own level of challenge. Here is the decimal number bonds to make 1 and make 10. So this is where I'd like lots of you to start if possible, please. If you feel like you need to go back and recap number bonds to 100, that's absolutely fine. Even 20 and 10 as well. So choose your level of challenge today, and we hope you enjoy playing that game, spending about 10 to 15 minutes. We're going to be continuing for our main math session today, looking at rounding decimals. Yesterday we looked at actually how to round decimals and how the use of number lines can also really help us to see whether to round a number up or to round a number down. We looked at rounding to the nearest whole number and to the nearest tenth, and some of you also looked at rounding to the nearest hundredth. Today we're going to be putting rounding decimals into a problem solving activity. So in order to be successful today, we're going to need to use our place value knowledge, use number lines once again, and some of you might be finding more than one possibility to your answers, and some of you as well also may need to make some links between units of measure and converting units of measure that we've covered in previous weeks. We're going to have a very quick recap then now, looking at how we round a number to the nearest whole number. We've got 67.8. So we can see then on my number line that the whole number that comes before is 67 and the whole number that comes after is 68. And actually if I was to place this number on the number line, halfway would be about 67.5. So it's obviously larger than that, so it's closer to 68. That's without actually applying the rule of rounding, where we look to the number, the digit, to the right, and here we've got the digit 8 for 8/10. 5 or above, we round up high. So we can see there then that we're going to round up. The nearest whole number is 68. Second example then, looking at rounding 56.76 to the nearest tenth. So this time we're looking at the whole tenth that comes before, 56.7, and the tenth that comes after, 56.8. So once again then, we're looking to that column to the right, which is a 6. That tells us we're going to be rounding up high. But actually, if we know our halfway point would be 56.75 and we've got 56.76, we'll roughly place our number here on the number line, and we can see here then that we're going to round up to 56.8. So now what we're going to do is have a look at the sorts of problems that you are going to be applying rounding decimals to today. So I'm going to read this problem to you now. Dexter is measuring a box of chocolates with a ruler that measures in centimetres and in millimetres. He measures to the nearest centimetre and writes the answer as 28. The question is, what could the length of the side be? Now what this question suggests to me is there's actually more than one possibility, and indeed there is actually many possibilities that could be the answer to this question, because this is asking us to think about numbers that would round to the nearest whole number of 28. So obviously, yes, the box could have measured 28, but there's lots of other options it could be. One of the options I thought of was 28.1. Rounded to the nearest whole number would still be 28. 28.2 is another possibility. Then I thought about the fact, would 28.24 also round to the nearest whole number of 28? And it would indeed, because it is closer to 28 than it is to 29. These are obviously all numbers that begin with 28. These are all more than 28, and so we would round down to 28 centimetres. We then need to think about numbers that actually possibly that would round up to 28. So actually we'll begin with 27 and 27.9 centimetres. If I think about that roughly on my number line would be here, that's going to round to 28 centimetres as the nearest whole number. So then we can think about actually what is the smallest length it could possibly have been. And it would be 27.5. Anything less than 27.5 we would have to round down to 27. And 27.5, because it's 5 or above we round up high, is 28. And then I thought about what would the largest number be? Well, it would need to be 28. It would be 28.4. But I wonder actually if there is a number bigger than 28.4 that we could round to. If we're thinking about hundredths, we could have rounded to 28.49. If we were going to thousandths, 28.499, and so on and so on. So it's easier to identify the smallest number than always the largest number, but that's possibly the largest number to 2 decimal places. If we turn to 28.5, that would mean we'd need to round to 29. So this problem can seem a little bit tricky where there's more than one possibility, but you're not being asked for all possibilities, you just need to find one of them. So if this one seemed most straightforward, that would round to 28, then that would be your answer. Our next example then, same problem again. Dexter is measuring a box of chocolates with a ruler that measures in centimetres and millimetres. He measures it to the nearest centimetre and writes the answer as 34 centimetres. What could the length of the side be? And once again, here is an example of what it could have been if it was less than 34. Possibly could have been 33.8. It could have also been 33.5. It probably couldn't be any smaller than that. It wouldn't be, because that would then round to 32. So we've got 2 options there, and another option maybe for larger than 34. It might have been 34.1 centimetres, 34.3, 34.4. And my other example down here was 34.46. So having a look then, would 34.5 work? And the answer is no, it wouldn't, because it is 5 in that tenths column, it would round to 35. So actually we would need to ensure that this tenth number was a 4. If we were looking for something maybe bigger than 34.46, we could have 34.49, and that would also make that. Now this final problem is slightly different, because this final problem does actually just have one answer that we're looking for. Dexter is measuring a box of chocolates with a ruler that measures in centimetres and millimetres. He measures it to the nearest centimetre and writes the answer of 28. The question says, what is the smallest length the box of chocolates could be? And you can see here on my number line that I've started with 28. So I am looking for a number which is smaller than 28, but still would round to 28 to the nearest whole number. We may have 27.9, but we can go lower than that. We may have 27.6, but we can go lower than that. The smallest number is actually 27.5. Anything less than 27.5 would round down to 27. We can see here we've got the whole number of 27, and when we look to the column to our right, it is a 5, which tells us we have to round up. 27.5 is the smallest length the box of chocolates could be, 27.5 centimetres, not 27.51 or 27.52. The smallest would be 27.5. So today you are going to work through these challenges. We look forward to seeing your work.